Yep, that's what happens when you think data alone will save you. Condition-based reactive maintenance. The irony writes itself.
Real-time health data shows where you've been. The predictive snapshot shows where you're headed. Time to failure, estimated. Remaining useful life, calculated. Risk, visualized. With Empower, you don't guess. You plan.
Hello and welcome to Chaos and Caffeine, episode 26. In any case, busy day today, so I fell back on coffee that I kind of need today. So it's Death Wish Dark Roast. So we've already covered this before. It's great stuff, and I put it in this cup. Now let's get into why I usually refer to reliability engineering as chaos engineering, and why I've defined myself as a chaos engineer. And don't worry, I've noticed a lot of other people starting to do the same thing. I think that's a good thing. So in any case, today we're going to talk about something very interesting. I've noticed a transition. I've actually been guilty of this in some cases, and that is the misuse of the terms condition-based and predictive maintenance when we talk about some of the new continuous monitoring systems that are on the market. So I've actually originally was going to do this with a banter with ChatGPT. There's some bugs I have to work out. We're going to try that next week. Turns out I have to do it from the phone instead of on the computer. So I had worked up a script. So I'm going to work from the script for this, because I think it's very, very important that I cover this topic correctly, because it is very important. It's setting our industry backwards. So, all right, let's start with definitions, because if we don't define the words, the marketing department will do it for us, and be perfectly blunt, they already have. Many of them have. So condition-based maintenance is maintenance triggered by measured condition, not time, not vibes. Basically, we've talked about, you probably heard things about vibe coding, and you know, I created one called vibe consulting because I've seen way too much of that too. Now, don't get me wrong, I'm all about using different AI tools, and we do. As a matter of fact, we create some. I have a whole division that does it, MotorDoc AI. So in any case, condition-based maintenance is maintenance triggered by that measured condition. You know, it's not by time, not by vibes, we've always done it this way, but condition indicators across a defined threshold or trend towards an unacceptable state, such as if I'm monitoring something continuously and we notice a beginning of degradation, that should trigger some thought process. Or right off the bat, when we're taking data and we say, hey, you know, we're seeing low grease levels. So I have seen, don't get me wrong, I've seen some continuous monitoring systems that are specifically designed to address some of that. So as they see a change, a degradation, they introduce something. That's CBM. Matter of fact, I've seen some greasing systems that do basically continuous monitoring, and then when they see a rise, instead of allowing the bearing to go to failure, they'll inject lubricant. So CBM is basically the asset tells you it needs attention. Okay, so something is going on that needs to be mitigated before the equipment fails to avoid the functional failure. So exactly, predictive maintenance is when you use condition and operating data to forecast what is coming, or in the case of some of the tools we have, remaining useful life, the probability of failure, time to intervention windows, meaning time to do something to avoid equipment outage. And here's the catch. In reliability engineering, that forecast is not an absolute. It's probabilistic. It's a risk. It's likelihood. It's uncertainty. I've made this point bluntly many times. The term predictive maintenance gets abused like it means it will last exactly 100 hours and fail 1 minute later. Basically, that's not engineering, that's fortune telling. So if we come out, say for instance in our Empower 3.0, where we have a risk curve. Well, what we do is we say, here's the risk of failure as a projected time comes along. And based upon the type of data, we set a threshold that says, okay, when it's 20% resistant to failure, that's the end point. That's what I use to define in my thing, and left it open so people could use their different definitions. So if it's 40% resistant or 60% resistant, and that shortens the time. So basically CBM tells you it's getting bad, and PDM tells you how bad, how fast, and how soon. And that's probably the cleanest way to put it. Now, here's today's controversial espresso shot. Now, I like ChatGPT throwing that one in there. I'm going to use that from now on. See, I listen to AI once in a while, but I do verify what it says. A lot of continuous monitoring systems only identify, let's say, a bearing defect once it's already wrecked. Once the bearing is in really bad condition, or right as it's supposed to grenade, or about to grenade, I should say, or blow up. And if that's what your system does, it's not condition-based maintenance, and it's definitely not predictive maintenance. And unfortunately, that's primarily my concern in the field. But it's monitoring. It's continuous. So why isn't it condition-based maintenance? Well, because timing matters. Basically, condition-based and predictive maintenance live and die by, and this is another one I'm seeing people fighting back against the P to F curve. It's not valid, da 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 da. Well, they're wimpy fucking consultants that don't comprehend the concept behind reliability engineering, and I've already written about that one. So basically, when I hear that term, and when I hear that kind of thing, I know immediately the people that are talking or writing, especially on social media or LinkedIn now, I'm seeing a lot of that where people have gone out and they want to sound like they know what they're doing, so they go to AI, and you can always tell because of all the little things through it, because that's the default, by the way, for ChatGPT, is to have the little emojis in it. So when I see those emojis in there, I know the person didn't do anything, let alone read it. So they'll put out, and that's another subject, because some of the stuff that I've seen on there is outright dangerous, and that's another topic. That's my opinion. Is if you're putting something up and you're giving solid advice saying this is it and this is how you do it, and somebody gets injured, I guess who should be responsible for that? You're giving advice and you're presenting yourself as a professional. But I am way off topic, and I do that. Well, because timing matters in the case of CBM and predictive maintenance, the P to F curve is really, really, really important. The time between potential failure, or point P, and the functional failure, point F, or the point where you detect it, really is the potential failure. That's point P. If your detection happens at the functional failure, you didn't enable maintenance, you enabled documentation. And this isn't just opinion. There are well-known practical limitations. For example, many traditional vibration approaches detect bearing damage mainly in later stages. As a matter of fact, that was one of the things that we ran into when we were creating Empower Vibe, is I wanted to meet standards, so we had to build in two methodologies. One is the one that we're seeing everybody use, which follows an ISO standard, and that gives an overall. And we noted right away in our testing that, because we were going to say, we were basically providing a tool that would do that, but I also wanted the other one for very, very early detection, pattern detection, not fault detection. And we noted right away that we could have a catastrophic bearing failure in process, and according to to that standard, it was good. So what do you do? one industry source noted that vibration monitoring often identifies stage 2 to 4. Actually, it's 1 to 4, but where irreversible damage has already occurred, and you're basically managing the asset to survive until shutdown. Now, we have done that, and we have used different technologies to do that. And that is a valid methodology. As a matter of fact, I believe it did. As a matter of fact, it took that from one of my articles. So it's not predicting failure. It's it's announcing a failure party after the guests have already arrived. So some systems are really asset protection or late stage fault alarms. And you've heard me use the term dummy lights, just like the dummy lights in your car. If your oil light comes on in the vehicle, the damage is already occurring. Useful, sure. But calling them condition-based or predictive maintenance is a category error. There's even, IBM has even labeled this kind of thing. It's called condition-based reactive. Alarms like high temperature, low pressure, helpful, but no time to plan. So there's a term for it. Matter of fact, that's what they should be calling themselves, CBR, not CBM. Yeah, that's now the title for this. A discussion of condition-based reactive. And IBM created it, not me. So thank you, Maximo. Why this mislabeling matters? Well, we'll talk about consequences then. When you call late detection CBM or PDM, three things happens. One, you create a false sense of control. Leadership thinks you have early warning, but you don't. And really, that's what's killing our industry right now. You contaminate KPIs. You'll claim predictive maintenance savings, but you're mostly measuring how fast people react to an alarm, not how actively you avoid failure. And so I've actually seen people say, well, we can't introduce condition-based maintenance because we don't have the personnel. And the first thought that goes through my head is, then you weren't introducing condition-based maintenance, because the whole objective of condition-based maintenance is to more effectively use your personnel, meaning take your people and make it so, they see, oh my gosh, this condition is going to occur. We can mitigate it by, saying, changing the tension on a belt, versus taking an entire machine apart. Big difference. One person in an hour or multiple people in days. Okay, which is more effective use of your people? Okay, so third, you turn reliability science into marketing theater. And this is what really pisses me off, right? So I've been pretty direct about this. We've watched reliability science devolve into marketing voodoo science, where technologies adopt the P to F curve to prove their widget is better while pretending every asset fails the same way. Okay, or, we see the victory laps as they hold up a completely destroyed bearing. And when I've talked about this recently, I got, some public pushback, and okay, I appreciated it. As a matter of fact, we continued some offline discussion. But I had started getting really nasty, messages, and I don't call people out on them, because I like getting those messages because it reinforces what I say. So I paraphrase them. So if I ever get called on it, you better believe I'm going to start showing them. So basically, the PDF curve became a sales slide instead of an engineering tool, and my confession is I'm the first one to have done it in a reliable web conference back in like 2002, 3, or 4, something like that. I'll have to go find it. I think 2002 was on the slide deck, and I'd used it before for something similar, but really more towards what it was meant for. But I was using it to sell an instrument, and I fell into that trap. So the real litmus test is, can you act in time. So here's the simplest test. If the alert arrives too late to plan parts, labor, and a controlled outage, then it isn't condition-based maintenance or predictive maintenance. It's a last-minute fire drill. If you can't schedule, can't change parts, can't choose a safe window, can't prevent a secondary damage, okay, say that a belt is failing and basically you don't get alerts until the bearings failed, that's not condition or predictive maintenance. Then you're not maintaining based on condition, you're reacting based on panic, you are not scheduled, you are not properly utilizing your people. So what should a condition-based maintenance system do? For a system to qualify as CBM, it must detect a meaningful indicator in the P zone for the type of failure that you're trying to detect. Okay, so that's the whole RCM conversation and everything else. Not hot to touch, not screaming bearings, not metal confetti. The point P is much earlier. Basically, not something, and if you follow me on LinkedIn, you know I've said this before. Why are you calling that condition or predictive maintenance? I could have heard that a block away. That is exactly right. The technology should be identifying things that are not perceptible to the human being. Okay? Use defined thresholds and trend content. So basically, and we've introduced a few things too, because often people only get snapshot readings. So what we do is we've introduced some industry stuff which has a very, very specific confidence level. So for the electrical and mechanical engineers that are in the reliability industry, I really highly recommend, if you haven't already, if you're being used, if the term for your position is reliability engineer or maintenance manager, and you're doing anything about condition and predictive maintenance, you really need to go back and do a short course at least on probability and statistics. The whole point is reliability engineering stems from industrial engineering, where we don't use calculus. We use much wilder math. So use defined thresholds and trend content. So threshold only systems create nuisance alarms or don't detect things. Trend only systems can miss rapid progression, and basically condition-based maintenance needs both. Okay, so you'll see me sometimes talk about ARG, it's AI or machine learning. Basically, if they're used correctly, a condition-based maintenance program built around anomaly detection can be quite good. As a matter of fact, our CMS2 and the empath ECMS systems, or continuous monitoring systems, that's what we do. We're looking for some change to have occurred before we then trigger an analysis. So, something will change and boop, there it is. Well, actually, CMS2 does an analysis every so often, and so does the ECMS. But basically, you're running along and you see a change. Well, that means that something is changing. Need to take a closer look. But then we layer that with basically a rules-based system, and a new system that we just introduced based upon years of work, which I call a logic engine, which is a very, very interesting hybrid. So anyways, so tie the indicator to a failure mode. Now, going back to, actually, let me go back to the threshold only systems. We see this a lot. If the system works off of just training over a period of time, and a long period of time, to see every variation in your production, we've watched this in action. And let's just say it's electrically related. So you have an electrical signature analysis system hooked up, and you're monitoring an electric machine, and something happens somewhere else and they have to replace some components elsewhere and they make a change and you're on the same transformer, all of a sudden you're going to start seeing alarms tripping on the system you're on because something's changed in the system. Or they add something to the system and all of a sudden you start getting a lot of false positives. That is a thing that happens. We've seen it. As a matter of fact, in a couple of cases, we've seen people calling out some of those systems at, well, actually, EPRI study did too, at well under 20% accurate. Tie the indicator to a failure mode. If you can't connect it to a physical failure mechanism, you're not doing condition monitoring. You're doing anomaly vibes. Hey, that ties right into what I was talking about, doesn't it? So basically, I feel like there's something going on. Therefore, I will throw a false positive, which is going to pull people away from their other tasks to have them go work on something that isn't a problem in the first place. That sounds like effective use of personnel. So, create an actionable window. The system must produce enough notice and information to support planned work. So, for instance, if you have a system where you can't access the data and you have to trust what some remote person is telling you, and that remote person, basically you don't own your data, how can you do any of this? Seriously. I've always told people, even if you have a third-party monitoring thing, you need to have people that understand what they're looking at. It's absolutely crucial. Otherwise, that little bit of extra training, that little bit of knowledge is going to save you a lot. I mean, there are systems out there in place right now. We've been into a few of them. I don't talk about every type of job we go into, and there's times like last December where everybody goes, "Are you in the field at all?" Oh, yeah. I just didn't want to talk about it because if I did, I was so pissed off, I would have mentioned names and that would have gotten bad. So CBM is basically early enough detection to do maintenance intentionally. Basically with intent, planning, and control. So I'm hopefully seeing some of that direction. Now what I did for fun this year, seeing as the first couple of weeks in 2026, again, I'm getting off topic, but is I didn't tell people what we were going to do. So people started assuming, and I was watching presentations and stuff like that, and people were telling me about presentations where basically, in effect, they were guessing because I was throwing out breadcrumbs heading in a different direction. And now I'm watching some of those companies and their marketing scrambling to try to get back to what we do. And you know what? I'm a former Navy, you're never former Navy. I'm a Navy veteran. I always had a very interesting sense of humor where when I think somebody is just, not thinking, I will mess with them. So I do. So thank you for going to get the bucket of steam, folks. And you know who I'm talking about. Gee, I've noticed their AI stuff is, and some of their statements on a couple of the companies are being blended specifically to look like ours. Okay, so let's get back into the topic. Sorry, I saw a couple last night, and I go home and I'm just dying laughing. Bronca goes, "What's going on?" Well, they're doing this. Are you going to be pissed off? No, I think it's hilarious. So, to be predictive maintenance, you need everything condition-based maintenance needs. So, condition-based maintenance is usually a subset of predictive maintenance, at least in my opinion. And I have a story about predictive maintenance. So I did a project, and that project is, by the way, now put into one of the logic engines I call Motor Life 9, as in 9 lives, in the Empower system. And one of those was insulation life. So I did a presentation at IEEE Electrical Installation Conference one year saying predictive maintenance of insulation systems. Oh boy, did certain people, crawl down my throat. If you say 100 hours and it lives 99 or 101, da da da. So the following year, I did the exact same article. I mean, exactly the same, except I just switched predictive maintenance to time to failure estimation, which is basically what it is. And the end result was it got reprinted. I had to do it as a magazine article. It got this and that, so it's all over the place. And the concepts that I have for that, and then some later work became the Motor Life logic engine. So what must predictive maintenance add? So prognostics. Estimate rate of degradation and likely time to threshold or time to failure. Okay, now, with that, you must have an uncertainty. You present outcomes as probabilities, not promises, and you can come up with a curve. Matter of fact, it's a natural log curve. Now, you can apply all kinds of advanced math to it to try to make it more and more accurate, but generally, you want your reliability decisions to be in the language of risk and probability, not absolutes. And, that you're going to see that in an article. I thought it would be up already. It's not, but it'll be up shortly. Decision support. Convert predictions to a maintenance window with recommendations. Here's the most likely time range. Here's the confidence. And here's the consequence if we delay. And that's what we built into the new technology. And I'm the one who reframed it to time to failure estimation. That's a term I get to make claim to. First engineering and science article on time to failure estimation was mine. And that's my career. That's what I've done. A lot of research, we fund it, so I don't have to worry about academia, but I digress again. Specifically because predictive maintenance was being interpreted as absolute time to failure, which, non-reliability, non-industrial engineers, non-statistically related groups will reject. So time to failure estimation reframes it as probability-based estimation after detection. That means I can have a curve with percentage chance that it will survive a certain amount of time with a confidence level. So predictive maintenance isn't the machine will fail on Tuesday, it's the risk curve is moving, and here's our best estimate of what that means. So that's the grown-up version. If you are going on about predictive maintenance must be in a crystal ball, that's not particularly grown up. And that's what I'm seeing a lot. People with, they might have reliability or engineer or maintenance consultant in their title, but then they come back and they fight back. It's either being done as a marketing thing or it's being done because they don't understand reliability. And, people are going to disagree with me, but everything I'm saying is covered in reliability standards. That means consensus agreement on everything I'm saying. I'm not making anything up. Okay? Hell, this is what I was trained on in the military in the 3M system. So that's the 1980s, and it was old then. Well, since the 1950s primarily. But why continuous monitoring often fails that condition-based or predictive maintenance bar. And somewhere along here, I've put up a picture of a catastrophic bearing that was being stated that it was perfectly fine by one of these systems. Now, why do so many continuous monitoring programs end up detecting late? Well, a few reasons. Wrong sensor for the failure stage. So if you're only looking at overall vibration, you may be living in or overall current or voltage, you may be living in later stage bearing indicators. Some sources explicitly list late stage bearing failure as what overall vibration catches well, and that's more or less correct. An alarm strategy without context. As a matter of fact, that was one of the things that, one of the feedbacks I got, and I appreciated that. And that was that, well, the customers don't always act on it, so we just don't report it early. Arg! So I'll finish this section. I'm going to cut a story for that. If your process varies by season, recipe, load, or speed, fixed thresholds, either spam alarms or miss real problems. IBM, for instance, pointed out how variable process conditions make automated alerting challenging without intelligence or expertise. And I always call for a human in the loop. The P to F curve gets treated as universal truth. If you look at what we just covered, and I'll put the P to F curve talk I did or episode we did in the end here. The P to F curve gets treated as a universal truth. The P to F curve was never meant to imply every asset fails the same way and marketing teams use it to prove their widget. That's an incorrect way to do it. Mowbray basically said that the F range may vary significantly, and the idea is you want to use the P to F, you want to be able to set that F as a variable condition, and the tighter it is, the more capable you are of doing an on-condition task, okay, an on-condition assessment. So I'll get to one story. So when I was I won a ton of awards when I was at General Motors for this stuff. I was the QNPM, or my team was the QNPM consultants for General Motors facilities, and we went out to a facility that is no longer, it got sold off, and part of the reason was because their maintenance costs were too high. Matter of fact, a lot of the plants that shut down in 2009 and 10 were specifically because their maintenance costs were too high. There were other factors in there too. I had to ride through a lot of that. It was not fun. It's never fun when you're talking about people becoming unemployed. So neither here nor there. That's back on my mind because of recent stuff. But we go out to this one site, and I go through, and I'm like, it's the worst site. That's why we were there. And the reliability team comes up and they go, well, we're detecting this stuff, but we're not even telling them anymore because they're not using the information. They're not acting on it. And so I go to management and I go, well, I saw that we had all these failures over here, but and they'd actually detected it, but they're not telling you because the guy goes, well, shoot, we're getting ready to do a major, change to the plant. We just need to, what we want to do is plan for things, get an idea of what the risk is that things are going to fail so that we can just get the materials we need because the production line is completely changing. Like we won't, any of the spare parts we have can't carry over. And I said, oh, so what you're doing is you're basically trying to get everything you can out of the asset, understanding the risk of failure, and for things that have a high risk of failure, getting the spare parts in for when it fails. Yeah. So I went back to the predictive maintenance staff and I told them that. Suddenly it made sense. That was a communication breakdown. So I'm watching these communication breakdowns because a company might hear from somebody somewhere. Oh, well, yeah, we're aware the bearing's failing, but we're not going to act on it until it's failed. Okay, that's their maintenance strategy. Then don't call it condition-based maintenance or predictive maintenance. It can be fault finding. That's perfectly legit as long as it's an understood and communicated strategy, and that the risks and damage and costs associated with it become a thing. So what does good look like in practice? A condition-based maintenance, and there's standards, like I said, for this, including asset management standards. A condition-based or predictive maintenance ready system should be able to answer these questions clearly. What failure mode is this and what can it detect? So what failure modes can it detect? Because I've watched way too many of these guys say they can detect everything, and there is no one technology that detects anything except for mine. Just kidding. Where are we on the P to F curve for this asset and this condition? Okay, and I've done I did a class on that 3-hour class on this recently online. And if you're watching this and you're interested in that, contact us and I'll send you the link. I'm not making it public because we've decided in 2026 we are no longer educating our competition. Because they take the information, they misuse it. Where are we on the P/F curve for this asset? We talked about that. What is the lead time once a fault is detected? So is it able to provide projected time to failure? Mostly dummy light. What's the confidence levels? And you're going to see that in all of our reports now. There is a confidence level for each thing. What action should we take and by when? I'm going to make recommendations on how to either prove that that's what the condition is, or here's the action you need to take. If your system can't do this, it might still be valuable, but it's now condition-based reactive, and it's a fault alarm, a dummy light, a protection system, or an end-of-life indicator, but it's not predictive maintenance. So where do we land in this? Empath, which is our electrical signature analysis, and Empower, which is our current signature analysis, both different systems. They sound similar, but they both have different goals. That's why when somebody calls up, I want this system or that system, we say, okay, what is your application? Here's the key. Electrical signature analysis and motor current signature analysis can provide earlier and different visibility because they can see the motor and driven load interaction through the electrical domain, basically through the air gap of the machine. Our system in particular looks at slight changes in watts in addition to everything else, which means that we're detecting things before it shows up thermally or audibly in most systems. MotorDoc, my company, positions its work around preventing motor and generator failures using ESA and MCSA, including continuous monitoring and prognostics. Now, don't get me wrong, most of the time my field service groups are out troubleshooting using these technologies, but we can, and our customers do, especially service companies do, use them for continuous monitoring diagnostics or even routes. Empower is described as a system designed to collect, analyze, visualize, and automate analysis of motor current data, which is foundational for moving from alarm at failure into condition-based and predictive decision-making. As a matter of fact, with our brand new vibration system that we built into the Empower, it's either standalone or works with it. We built in pattern recognition. So even if there is an alarm for something, we'll say this condition exists, it's at this level, meaning you don't need to address it, but it's there. And with all the supporting information as well. So the punchline is the technology choice has to match the failure mode and the detection window. And in the back half of this, this episode, we're nearing our conclusion. We'll talk about how we use these methods, basically paired with engineering fundamentals to drive detection early on the curve, and basically to express we know the way engineers and executives can both use in risk, probability, and actionable windows, not in magical certainty. So when we come back next week, we will probably cover something quite interesting. I'm not going to pre-announce it this time because I'm watching people trying to get me to respond, and obviously I'm responding a little bit. So when we talk about, again, in conclusion, condition-based and predictive maintenance, there has to be a window in there. There has to be recommendations. The idea is not to act as a dummy light. If you want to be a dummy light or whatever, which a majority of the systems we're watching out there are doing, then just say you're condition-based reactive. Don't say condition-based maintenance. Don't say predictive maintenance. Now, we just kicked off yesterday the Seagray Practical Electrical and Current Signature Analysis of Machines and Powertrain Working Group. We have multiple OEMs of the technology. We have repair shops. We have We have machine OEMs. We even have national labs from around the globe involved in that one. I'm chairing that one. We are not bringing. We will invite people in to do things, but our team is now set. That document will be coming out probably 2028, so we're 2 years out because it takes that long. However, in the meantime, there's some standards that we're working on, and we will be nailing this stuff down even harder in standards, and you're going to see me harp on this continuously. If you are calling your technology condition-based or predictive maintenance, and it is an alarm thing, or it's actually condition-based reactive, then you are harming the industry. I'm just going to put it like that. That's not just my opinion. That is the impact we're seeing. That's what people are coming to us talking about. And, yeah, I also see that as harming my company. So I'm not particularly friendly about it. Some of you know about that as well. We've spent 40 years supporting the technology. Other people have spent a lot longer. There are people that are no longer with us that were that we're standing on their shoulders, and you're taking them off at the ankles. So, I'm a believer in loyalty to those who have built the industry. And, that's why I stick to the basics, back to the basics, I should say, while, advancing technology, not setting us backwards. And, that's not how I intended to end this, but, as I'm reading through this and, yeah, there's things that upset me a little bit once in a while. This is definitely one of them. Hence why I covered it. I have seen a few companies come out, including competitors that are doing everything they can to also press this message. Obviously, I'm not going to mention by name their competition, but I'm paying attention and I appreciate their efforts. And as a matter of fact, one of them in particular, I appreciate their efforts because people buy their stuff and they go, oh, and then they buy ours. So in any case, yeah. So I wait until the end to do any of the marketing bit because my company's sponsoring this. With that, have a great first part of 2026. Remember remember that words mean something, and in this case, definitely mean something. And with that, have a great rest of your weekend. If you're watching this as it gets published, or if you're watching it later on, this is the beginning of 2026. We're hoping it's a better year than what we see on TV. Have a good day.